Okay, we are going to look at transformations of functions, also known as graph shifting. So let me first start with just a generic equation, and we're going to talk about where you look for the different types of graph shifts. And so we're going to have some coefficient a, it could be positive or negative, and then there will be an x, and there could be it could be positive or negative as well. That'll determine a shift. And then there's going to be some h that is either added or subtracted. And there's either going to be a power, or it could be a square root or absolute value. So we'll just let that box represent, whatever it is that they're doing to the function. And then finally, there will be some k value that is added or subtracted. And so they will... they'll go through the order of the shifts and, asking you about the shifts in the correct order. So the first thing that you always look for is you check to see if there is a horizontal shift. And if there is, you will notice that there is a number that is either added or subtracted to your x variable. Now, the tricky part with the horizontal shift is that you have to remember that it's going to shift opposite the sign. So if you actually see a number added to your x, normally we would think horizontally that it would go to the right, but it goes opposite. So plus h will take it to the left, h units, whereas if you see a minus h, that will actually take it to the right. So we're going to always look for that particular shift first. Okay, so the second thing that we will look at is the actual a value, and that produces what we call either a vertical stretch or compression. And so notice we don't look at the plus or minus in front, we only look at the a. And so just to kind of help you remember, I always think of it as the absolute value, so you're not looking at the actual sign. So if that number is bigger than 1, then we consider it a vertical stretch. Whereas if that number is smaller than 1, then we actually call it a vertical compression. So with a stretch, you'll notice the graph will get taller and thinner, like you're stretching it out vertically. Whereas with a compression, it gets shorter and wider. And so I always think of it as like going to a copy machine. Bigger than 1 is like you're blowing up the picture. You're going to stretch it out. Smaller than 1, you're shrinking it or you're going to compress it. So that is going to come from the actual a value in that particular equation. Okay, so the third thing that we look for is something that is called an x-axis reflection. So you're looking at the plus or minus in front of the a. And so if it's just a positive, then there's not an x-axis reflection. If there is a negative sign, then you're going to say yes, that there is an x-axis reflection. And that just means it takes the graph and flips it across your x-axis. All right, the fourth thing that we're going to look for is a y-axis reflection, and that will come from the sign in front of your x. And so if it's positive, you don't have one. But if there happens to be a negative in front of that x, then you're going to say yes. And that what it basically does is it takes the graph and it flips it across your y-axis. So there is a y-axis reflection in that case. And they just have you saying yes or no. And then finally, last but not least, we look at a vertical shift, and that's going to come from the k. And it actually shifts with your sign. So if you see a plus k, then your graph will go up k units. Whereas if you see a minus k, then your graph will actually go down k units. Okay, so let's actually apply this now. So when you go to a question, sometimes they're going to first ask you what is the more basic function that's going to be shifted, reflected, stretched, or compressed. So you're looking at only what are they doing to the x. So find your x and then look at what is it that they're doing. And in this case, they are taking the square root of the x. Okay, so are they raising it to a power? Are they taking the square root? Is it in the absolute value? So you're going back to our common functions, and you're just saying, what are they doing to the x, period. And that's what you put in that first part. Now, they're going to show you a graph of that basic function. So notice there's our half of a u on its side because that is an even root. And we're not going to ask you to graph them, but they will show you how that graph shifts as you do the different transformations. So I'm going to start with a horizontal shift. And remember, with my horizontal shift, I'm looking with the x. And it's opposite the sign. So if I see +4, that graph has to go left. Now, when you do that, there's going to be another box that pops up here that wants to know how many units. So in this case, you would put the 4 units. And what you're going to see happen when you type that in, they're going to take this half u and they're going to shift it to the left 4 units. All right, so the second thing that we are looking for is a vertical stretch or compression. And in this case, you are looking at not necessarily the negative, you are looking at the actual 2. So think of it as the absolute value. So the 2 is a number bigger than 1. So when you have a number bigger than 1, you get a stretch. And again, when you put that, it's going to pop up a box because it wants to know what the factor is. And again, do not put a plus or minus sign with it. You only put the 2. And so what happens there is that basically takes all of your y values and it stretches them upwards. And so it would make this graph just a little bit, stretch it a little bit vertically, and you'll see it do that when you type in that 2. All right, so the third thing that we are looking for is an x-axis reflection. This is where you actually do pay attention to if there is a negative sign. And if there is, you say yes. If there's not, you say no. And so if you say yes, what's going to happen is it's going to flip that graph across your x-axis, just like that. And then next, you're going to be looking for a y-axis reflection. So now you're looking directly in front of the x. If you see a negative, you're going to say yes. If not, you're going to say no. So in this case, that is a no. And then finally, last but not least, you're looking for a vertical shift. So you're looking for a number that is either added or subtracted to your function. And be careful because sometimes they could put it up front. So they could have written this as g of x equal 3 minus 2 times that square root. So don't get used to it always being at the far right. It could be up front. Irregardless, it's a positive 3. So with vertical shifts, it goes with the sign. So in that case, we would say it's going up. And then again, it's going to ask you how many units by 3. And then what you'll see this graph do is you'll see it shift up by 3 units. Okay, so in our next example, again, we're considering this particular function. They want to know, or they're telling us to graph the original function, and then they're going to indicate the shifts. And so in this case, the original function, I'll just call it f of x. Notice, what are they doing to the x? Well, they are squaring it. Don't pay attention to all the other numbers, just what are they doing to the x? And as we know, when x is squared, we get a U-shaped graph like they're showing me in this picture. So starting with looking at my different shifts. So horizontal, I'm looking, is there something with my x? And in this case, there's not. You would see parentheses if there was. So that is none. There's not a horizontal shift. With my vertical stretch or compression, this is a little tricky because we see the 4 on bottom, and what we have to realize is there's understood to be a 1 on top. So in that case, your A value is actually 1/4. That is a number smaller than 1, and when it's smaller than 1, that compresses your graph. So you're going to say it compresses it, and then it's going to ask you by what factor, and you're going to say 1/4. And so what happens is, like for example, the 0.01 that's on here, it becomes 0.14. So this graph gets a lot wider because it is compressing that graph vertically. Okay, so for my x-axis reflection, I'm checking to see, is there a negative in front of that A? And yes, there is. So I would say yes, and then it's going to just take this graph and flip it down, just like that. For my y-axis reflection, I'm checking to see, just with the x, is there a negative in front of it? And it would have to have a parentheses there. So no, there is not a negative that's just in front of the x. And then finally on the vertical shift, I see that I've got a -2. So it's going to shift it with the sign, which tells me that will take that graph down by 2. So your final graph ends up looking something like that. Okay, the last thing I wanted to point out is just be very careful. So again, this one's asking for a basic function. Notice where your x is. So because it's on bottom, when you go to write your basic function, you do have to show the 1 on top. So because what are they doing to the x? Yeah, they are squaring it, but it happens to be the bottom. So be sure you show that 1 that is on top. And then, of course, from there you would do your look at your different shifts from that particular aspect.